In this video, we're going to review limiting reactants. The point of this video is to really think about what are limiting reactants and how do we think about them, and less about the function of the equations. So, a limiting reactant, or the limiting reactant, is the reagent that runs out first. So if you have two things coming together to make a product, so if you have A plus B goes to C, the limiting reagent or the limiting reactant and reactant are the same thing. The thing is, it's just the one that runs out. So the limiting reactant, in this case we'll call it LR, is fully consumed. So none remains. This means that 0.0 grams are left over. The excess reagent must have some left over. Because it is not fully consumed. And so if we're thinking about how much of A is left over or B is left over, it depends on whether or not they are the limiting reactant or the excess reagent. And so the other thing that's really critical when we think about this is the limiting reagent determines how much product is made. So when we think about this, it feels a little counterintuitive. Like, why would it be the limiting reactant? Well, if all of the limiting reactant is consumed to make product, you can use the limiting reactant to identify how much of your product could be created. So that would be your theoretical yield. So in a limiting reactant calculation, the identification of your limiting reactant is critical because everything else is based off of that. So let's look at a specific example. So in this example, which is quite basic, it says, using this equation where 3A plus 2B gives you D plus 2C. So you can imagine that this is a chemical equation with things like sodium chloride or silver nitrate. So we're just making them a little bit more simple. So this says, if you start with 25A and 24B, what is the limiting reactant? How much of each remains? And what is the theoretical yield of C? So when we think about a limiting reactant, typically it involves a calculation. And so that calculation would be that we take our 25A and then we use our balanced chemical equation where we have 3A for every 2B, and that gives you 16B. And I have rounded these numbers, so I think that's 16.6, and I rounded it to 16. And so this tells you if all 25A are used, you need 16B. That is what this calculation tells you. So we started with a reactant to reactant. So when we get here, we can say like, hey, we need 16B. I have 24B. Therefore, A is the limiting reactant. But let's say you did not start with A and instead you started with B. So your 24B, using the same calculation, would be 2B times 3A, and that gives you 36A. So if all 24B are used, you need 36A. Only 25A are present. So you need more A than you have. This tells you that it is going to be the excess reagent because you need more than you have of the other. So we know that this is our limiting reactant. And so that's good. So it asks how much of each remain. So if A is the limiting reactant, there are 0A remain because we used all 25 of them. And when 25A are used, 16B are used. And sometimes in the book or in other things, I say consumed, but used means the same thing. So in this case, for B, I started with 24B and I subtracted 16B, and that gives me 8B remain. And so in this case, no A remains because it is the limiting reactant. For B, 8B remain because that's how many are consumed if you use all of them in this calculation. So the next part of this asks, what is the theoretical yield of C? So in this case, we're going to start with the limiting reactant. So we're going to take our 25A and I'm going to convert that to C because it asks for the yield of C. So there are 3A for every 2C. And in this case, I get 16C is the theoretical yield. And so in this case, we can think about this as our, the theoretical yield. So this is one mechanism by which you can do this calculation. So we started with 2 reactants. So what about if instead of the reactants, we did a product calculation first? So I'm going to move this up and we might pull it back down. So in this, we still have our balanced equation of 3A plus 2B gives me D plus 2C. And we started with 25A and 24B. So if the method I showed you made sense, you can stop right here, let this go, and move on. But if you're like, I have a hard time processing the excess reagent, so instead, let's focus on identifying the limiting reactant first. So I'm going to convert 25A to C. So we know that we take our balanced equation, and in this case, I get 16C is the amount made when A is the limiting reactant. So you would do this instead of the previous method. So if we know that 16C is the amount made when A is the limiting reactant, how much could you make if B was the limiting reactant? So if I take 24B and I'm going to convert to C, where 2B for every 2C, and that gives me 24B. So this is the amount made when B is limiting. So from here, we can identify the limiting reactant. And the way we figure this out is the limiting reactant makes less product. And so this means that, oh wait, this should say C. Sorry about that. So because A makes less product, that makes it the limiting reactant because it controls how much product can be made. And so this limiting reactant makes less product. Therefore, in this calculation A is the limiting reactant. This is consistent with what we saw previously. So now we've been able to identify the limiting reactant. We know if A is the limiting reactant, 0A remain. So now we have a limiting reactant. We know how much A remains. We also know what the theoretical yield is. So the one that is more complicated in this case is the excess reagent. So for the excess, you're going to convert limiting reactant to other reactant. And then you subtract. So in this case, we would do the calculation we looked at earlier, where we take our 25A, and we know that for every 3A, there are 2B, and therefore we have 16B used. So then we would take our 24 minus 16, and that gives me 8B remain. In this very chaotic example, this value appears to be the same, but these are essentially mole calculations, and it will not be true when you use grams. So you can do this calculation either way, and this is just kind of an overview of the technological components of this type of calculation.